consider the following cases. In one of the case, a cricketer hits the ball with his bat. In second case, an iron nail is being hit with a hammer. In the third case, firing of a bullet. There is a common thing in these three cases is that the force, which is actually a quite large force, which has acted on the body for a very small interval of time. Such kind of force are taken into account of impulse. Impulse is the measure of total effect of force. So impulse is defined as the product of average force into, that is average force, and the time during which the force has acted on the body. This is impulse. So how do we derive an expression for impulse? See, we want average force into time. Suppose, okay, let's start with the according to Newton's second law. This is how we are starting. Let's start from the second law. According to Newton's second law of motion, don't write like this, okay? According to Newton's second law of motion, rate of change of momentum is equal to force d upon dt of momentum. That means f dt is equal to dp, right? So this is what we do in differentiation. So to find the average force, what is average force, by the way? It is the total force which acted for a very small interval of time, which is actually a constant value, okay? So if I integrate both of these sides for time interval 0 to t, t is the time during which or till the time the force was acting on the body, though no matter what how small it is, and dp is the change in momentum of the body, which is from p1 to p2, let us assume. So force will be a constant quantity from time 0 to t if it is taken as f average, right? If so, I'll paraphrase my statement. If this is a average force which is acting for a very small interval of time, then this quantity is going to be a constant value, right? So I'm taking this out, which is f average into dt from 0 to t, and then we have integration of dp, which is from p1 to p2. So I'm getting here is f average into t 0 to t is equal to p from p1 to p2, upper limit minus lower limit. So f average into t minus 0 is equal to p2 minus p1. So f average into time, this is basically average force into time, which was impulse I, is equal to change in momentum p2 minus p1. So we get a formula for impulse, which is this. Okay, so f average into time is impulse, which is change in momentum. The same expression is valid if you want to do it in vector form, okay? This, then this, and this, here, and here. So the formula will become this, this, and this, this. So this is what the expression in vector form, and the previous was in scalar form. So what do we get as an expression for impulse? So you can also write and use this formula in your numericals. Impulse is final momentum, which is mv minus mu. This is m into v minus u, and sometimes v minus u is what? At. So sometimes you can also use this formula m into a into t, which is impulse. This formula is sometimes useful and sometimes this. You can note it down.